Huawei just announced something that had engineers in Silicon Valley, officials in Washington, and regulators in Brussels reading the exact same report in a cold sweat. Three very different audiences arriving at this same uncomfortable conclusion within hours of each other. It isn't a new phone. It isn't a faster individual chip. It's a complete, vertically integrated AI computing platform built entirely from Chinese-designed silicon, with no Nvidia, no TSMC, and no American intellectual property anywhere in the entire stack. A combination that most Western analysts assumed was still years away from being technically achievable. And that isn't even the detail breaking people's assumptions. The detail that actually matters is the price. Huawei's new CloudMatrix 384 AI cluster hits performance benchmarks that genuinely rival Nvidia's flagship GB200 NVL72 system, a rack that typically costs somewhere around $8 million. At a price point Huawei's version reportedly comes in dramatically lower than. A company the US government spent 5 years trying to technologically cut off just climbed out of that pressure campaign and built a GPU cluster that enterprise buyers across Asia are reportedly already lining up for. If you want to understand exactly what happened here, why it matters, and what it means for the roughly $500 billion global AI hardware race that just quietly changed shape, stick around. Because the honest version of this story is more layered than either the celebratory or the dismissive coverage you've probably already seen scrolling past it online. If stories like this are exactly what you come here for, go ahead and subscribe before we get into it. Most people in the West think of Huawei purely as a telecom equipment company. That's not wrong, but it misses the part that explains everything that came afterward. Huawei was founded in 1987 in Shenzhen by Ren Zhengfei, a former People's Liberation Army engineer. Starting with roughly $5,000 in capital and a plan to resell Hong Kong telephone switches to rural Chinese businesses that had no other reliable access to modern telecommunications equipment at the time. That was genuinely the entire original business. Not some grand technology vision from day one, just a straightforward distribution play in a specific, underserved regional market during a period when China's own domestic telecom infrastructure was still fairly primitive. What Ren built over the following 2 decades developed differently than how most Western technology companies typically grow, where acquisition and licensing deals often substitute for building core capability from scratch. Rather than acquiring existing technology or licensing it from established players the way many competitors did, Huawei reverse-engineered the products it was initially copying, gradually improved on them through its own internal engineering work, and eventually surpassed the originals entirely in several important categories. The company consistently poured an unusually large share of its revenue, typically somewhere between 10 and 15%, into research and development every single year, through boom periods and through leaner years when profitability itself was far from guaranteed, and cutting that specific budget line would have been the easy short-term decision. That discipline compounded steadily over time, the way a modest but consistent investment tends to outperform sporadic large bursts of spending. By 2012, Huawei had passed Ericsson to become the world's largest telecom equipment maker by revenue. By 2018, it had become the second largest smartphone brand on the planet, trailing only Samsung. Then the US government decided the company had become too strategically dangerous to leave alone, citing national security concerns tied to its telecom equipment's potential use in critical infrastructure worldwide. In 2019, the Trump administration placed Huawei on the Commerce Department's Entity List, which effectively banned American companies from selling it components or software without a special export license. In 2020, those restrictions tightened considerably further, blocking any chip manufactured anywhere in the world using American equipment or software from being sold to Huawei at all. In practice, that meant TSMC, the world's most advanced chip foundry, could no longer manufacture Huawei's own custom-designed Kirin processors, cutting off the company's access to leading-edge chip fabrication almost overnight. The prevailing wisdom inside Washington at the time was straightforward. Cut off the chips in the phones, stall the company's broader AI ambitions, and keep Huawei stuck on older manufacturing nodes while the rest of the world sprinted ahead toward 3-nanometer chips and beyond. That prevailing wisdom turned out to be significantly wrong. What the sanctions actually did was force Huawei to accomplish in roughly 5 years what Washington had generally assumed would take 15 years, or simply never happen at all. The company built its own complete ecosystem. Not a workaround, not some quietly smuggled backdoor supply chain, but a genuinely domestically designed and domestically manufactured silicon stack, chips, software, compilers, and networking interconnects, the entire technology chain built inside China's own borders. In September of 2023, Huawei released the Mate 60 Pro smartphone. Inside it sat a 7-nanometer chip called the Kirin 9000, fabricated by SMIC, China's domestic foundry, the exact company the original sanctions were specifically designed to keep permanently stuck at older process nodes. Western industry analysts were reportedly quietly stunned because SMIC simply wasn't supposed to be capable of producing something at that level under the existing restrictions. That specific chip functioned as an early warning shot. The CloudMatrix 384 is the considerably bigger follow-up. The CloudMatrix 384 is Huawei's direct answer to Nvidia's GB200 NVL72. The rack-scale AI computing system that's functioned as something close to the gold standard for large language model training and inference since 2024, the kind of hardware that essentially every major American AI lab, from OpenAI to Anthropic to Google DeepMind, has built its own infrastructure around in one form or another. Here's what makes it technically serious rather than merely geopolitically interesting on paper. The system uses 384 of Huawei's Ascend 910C AI chips, connected through a fully optical, all-to-all networking topology built entirely on Huawei's own proprietary interconnect technology, rather than the copper-based or partially optical networking approaches more common in comparable Western systems. At the individual chip level, Nvidia's hardware still holds a clear and genuine lead, and it's worth being upfront about that rather than burying it. Nvidia's GB200 chip delivers somewhere around 2,500 teraflops of BF16 performance, more than 3 times what a single Ascend 910C chip manages on its own, and Nvidia's chip also carries considerably more onboard high-bandwidth memory, roughly 192 gigabytes compared to Huawei's 128, along with meaningfully faster memory bandwidth per individual unit, somewhere in the range of 2.5 times faster. So what does Huawei actually do to close that considerable gap, given it genuinely can't currently match Nvidia chip for chip on raw silicon performance alone? It simply uses roughly 5 times as many chips packed into one coordinated rack. By combining 384 Ascend chips into a single tightly integrated system, compared to just 72 chips inside Nvidia's own NVL72 configuration, the complete CloudMatrix system delivers somewhere around 300 petaflops of dense BF16 compute overall. Nearly double the throughput of Nvidia's own rack, along with meaningfully more total memory capacity, reportedly more than 3.5 times greater, and considerably more aggregate bandwidth thanks to that all-optical interconnect design running throughout the entire cluster rather than just between individual chip pairs. Here's the honest trade-off sitting underneath that impressive system-level number, and it's worth understanding clearly rather than treating the headline comparison alone as the complete picture. Huawei's approach works, in the most literal engineering sense, by brute force rather than superior chip design. Running roughly 5 times as many individual chips to nearly double one rival system's total output means the CloudMatrix cluster also draws dramatically more electricity to do it, reportedly somewhere around 4 times the total power consumption of a comparable Nvidia rack, translating into meaningfully worse performance delivered per watt of electricity consumed across the entire system. So what does that specific trade-off actually tell you about how to read this achievement honestly? It tells you Huawei has built a genuinely competitive system at the rack scale level, one capable of training and running serious AI workloads entirely without American chips or manufacturing equipment anywhere in the chain. But it's accomplishing that specifically by spending considerably more on electricity and physical hardware footprint to compensate for a real measurable gap that still exists at the level of individual chip performance and manufacturing precision. For a country with abundant electricity generation capacity and a strategic priority on technological independence rather than pure efficiency. That trade-off is a genuinely reasonable one to make. For a smaller operator paying market electricity rates and worrying about data center power budgets, it's a meaningfully less attractive proposition on cost grounds alone. Here's the piece of this story that keeps getting buried underneath the simpler chip versus chip framing most coverage defaults to. Treating this purely as a horsepower contest between 2 individual processors rather than a systems-level competition. Huawei doesn't just design the individual processor. The company designs the chip, the interconnect fabric linking chips together, the networking switches, the server chassis, the cooling architecture, the underlying firmware, the compiler layer, and the AI software frameworks running on top of all of it. The complete stack from silicon to application, controlled by one organization rather than assembled from a dozen separate suppliers the way most Western AI infrastructure typically gets built. Each layer sourced from a different specialized vendor with its own roadmap and pricing pressure. It's roughly the same underlying logic that made certain vertically integrated manufacturers structurally different from more fragmented competitors in other industries entirely, where controlling the full stack means no single external supplier can hold your entire product roadmap hostage to their own production schedule or sudden pricing decisions. When Nvidia experiences a supply constraint, whether from a chip shortage or an export restriction change, that ripple effect touches essentially every AI lab and cloud provider on Earth simultaneously. Because Nvidia functions as the single point of dependency for almost the entire global ecosystem, and everyone downstream simply has to wait in the same queue. When Huawei experiences a supply constraint instead, the company coordinates directly with its own internal teams across chip design, fabrication partnerships, and software to resolve it, without needing to negotiate with an outside vendor who has competing priorities and other customers ahead of them in line. That's not a minor operational footnote buried in a supply chain report somewhere. It's a structural advantage that took roughly a decade of forced self-reliance, driven directly by the original export restrictions Washington imposed with the opposite goal in mind, to actually build out this completely across every layer of the stack. The software side of this story is further along than most casual observers probably realize too. Huawei's own Mindspore AI development framework has been in active development since 2019, and now reportedly supports most major AI model architectures natively, without requiring developers to fundamentally rewrite their existing work from scratch. Developers who had to port their existing workloads off CUDA, Nvidia's proprietary programming environment that has functionally locked in the global AI research community for roughly 15 years, have reportedly found that specific migration process more workable than most people initially expected going in. Not seamless, and certainly not entirely painless. Just meaningfully more workable than the conventional wisdom assumed it would be. That specific distinction matters considerably more once the practical alternative becomes paying somewhere around $8 million for hardware you genuinely can't obtain on any delivery timeline you can actually plan a business around. Let's put some concrete financial figures on the table here too, because they help frame exactly how large the stakes actually are on both sides of this competition, well beyond the technical specifications alone. Nvidia generated roughly $130 billion in revenue during its most recent full fiscal year, up sharply from around $61 billion the year before that, essentially doubling in a single year, with data center revenue alone accounting for somewhere around $115 billion of that total figure, the clear majority of the company's entire business. The current AI chip boom represents the largest single hardware cycle in the entire history of computing, larger than the personal computer boom or the smartphone boom that preceded it. And Nvidia has captured essentially all of the profit from it so far, trading at a valuation that reflects investor confidence that dominance will continue largely unchallenged. Huawei's own consumer business, meanwhile, got genuinely crushed by the original sanctions, a real and painful cost the company absorbed rather than a footnote. Company-wide revenue reportedly dropped from around $136 billion in 2019 down to roughly $99 billion by 2021, and the smartphone division specifically, once the second largest on the entire planet, lost meaningful global market access almost overnight as component supply simply dried up. But the enterprise and cloud infrastructure side of the business didn't collapse alongside it. It pivoted hard instead, redirecting resources rather than shrinking uniformly across every division. Research and development spending stayed remarkably high throughout that entire period, even as overall revenue fell sharply. A decision that would have been difficult to justify to shareholders at a publicly traded company answering to quarterly earnings expectations. Huawei reportedly spent upward of $23 billion on research in 2023 alone, something in the range of 23% of the company's total revenue that year. Among the highest research spending ratios of any company its size operating anywhere in the world, dwarfing the R&D to revenue ratio of most Western technology companies of comparable scale. While the consumer-facing business genuinely shrank under pressure, the engineering capacity the company had spent 2 decades building up around high-performance wireless networking equipment got redirected specifically toward artificial intelligence silicon instead. That redirection is precisely what eventually produced the Ascend chip series. And scaling that same chip series up into full rack-level cluster architecture is exactly what produced the CloudMatrix 384. The export ban arguably didn't starve Huawei's engineering program so much as it concentrated all of that existing talent and budget onto a single, narrower, and ultimately more strategically important target. Here's where this genuinely gets complicated for broader American technology strategy going forward, in a way that's harder to fix with another round of tightened restrictions alone. The original sanctions on Huawei rested on a specific chain of assumptions, each one building on the last. That advanced AI compute fundamentally requires advanced semiconductor manufacturing. That advanced manufacturing itself requires American equipment and intellectual property somewhere in the chain, given how concentrated that specific equipment market has historically been. And that cutting off access to that American intellectual property would therefore cap China's overall AI capabilities at a level too far behind to genuinely matter on the world stage within any policy-relevant time frame. Every single link in that chain of assumptions is now being stress-tested directly by real-world deployments rather than theoretical projections drawn up years in advance. China's domestic chip foundry ecosystem, meaning SMIC alongside a growing cluster of emerging domestic suppliers still building out their own capacity, is genuinely not operating at the absolute leading edge of process technology. And it's worth being honest that this gap is real rather than propaganda in either direction. The Ascend 910C chip is believed to be fabricated using 7nm class manufacturing, not the 3nm or even 2nm processes TSMC currently produces for customers like Apple and Nvidia on its most advanced production lines. That specific gap is real and measurable, not simply a matter of perception or national pride. A chip manufactured at 7nm genuinely draws more power and delivers less performance per unit of physical chip area than an equivalent one manufactured at 3nm. A difference rooted in basic physics rather than engineering choices Huawei could simply design around. But here's the counter-argument: the actual benchmark results are now forcing serious industry analysts to take seriously rather than dismiss outright. Architectural efficiency and clever system-level design can meaningfully close a real portion of that underlying process node gap, even without closing it entirely at the individual chip level. If Huawei's optical interconnect design is genuinely superior in specific respects, and the bandwidth figures reported by independent analysts suggest it plausibly is in certain configurations, then a cluster built as a coordinated system can meaningfully outperform a comparable collection of individually more powerful chips that simply communicate with each other more slowly. Training and running AI models at genuine scale is fundamentally a distributed systems engineering problem just as much as it's a raw individual chip performance problem, and Huawei has been building sophisticated distributed communication systems for wireless telecom networks for roughly 3 decades already. That specific institutional experience appears to have carried over directly into how the company approached this entirely different but structurally related engineering challenge. Here's the honest, grounded answer to what all of this actually means right now, today, rather than in some hypothetical future scenario. For American enterprises specifically, Huawei's AI hardware isn't a legally available or practically accessible option at all. The same underlying sanctions that originally targeted the company make it effectively impossible for US-based companies to purchase its AI infrastructure through any legitimate channel. That particular wall is genuinely real, and it isn't moving quickly in either direction based on current policy signals. But that's honestly not the most relevant question to be asking here. The more relevant question is what happens to Nvidia's pricing power specifically in every market where a credible, functional alternative now exists for customers who simply aren't constrained by American export law in the first place. Every cloud provider across Asia, every AI lab operating in the Middle East, every enterprise buyer across Southeast Asia, Africa, and Latin America. Markets that together represent a genuinely large share of the total AI infrastructure spending Nvidia had been counting on to help sustain that roughly $130 billion in annual revenue going forward. If those specific customers now have access to an alternative that benchmarks within a meaningful range of Nvidia's own performance at a considerably lower delivered cost, Nvidia's pricing power inside exactly those markets genuinely starts to erode over time. And once that pricing power erodes even partially, the underlying margin structure that currently funds Nvidia's own research and development roadmap comes under real sustained pressure it hasn't faced in years. A competitor doesn't actually need to win outright on absolute chip-level performance to meaningfully reshape the broader economics of this entire race. American AI labs will very likely keep buying almost exclusively from Nvidia for the foreseeable future, but American AI labs were never close to the entire global market to begin with. Let's zoom out one final time, because this was never purely a story about one specific chip or one specific company. The United States built its entire technology export control strategy around a belief that the sheer complexity of the global semiconductor supply chain created permanent dependencies no strategic rival could realistically eliminate within any practical time frame. That belief was genuinely reasonable to hold back in 2019. Given what the underlying technology actually required at that specific moment. The accumulated evidence from roughly 2023 through 2026 suggests that original timeframe estimate was significantly miscalculated. Huawei also isn't the only Chinese company building this way right now. A cohort of additional domestic AI chip companies, several backed by significant state-directed capital, are actively building out the broader ecosystem surrounding exactly what Huawei has already demonstrated is genuinely possible at scale. The Mate 60 Pro proved the concept could work at the level of a single chip. The CloudMatrix cluster proves the same underlying concept can work at the scale of an entire coordinated system. The next open question is whether the surrounding software and developer ecosystem can hold together and mature quickly enough to make switching away from Nvidia's platform genuinely practical for a much wider range of customers, not just the largest and most technically sophisticated ones. When the original sanctions hit in 2020, Ren Zhengfei reportedly said Huawei had been quietly preparing for exactly this kind of moment for years already, and that the company would survive the pressure campaign intact. At the time, that statement understandably sounded mostly like public defiance meant to reassure employees and partners. Today, several years later, it reads considerably more like a planning document that simply got executed roughly on schedule. So where do you personally land on this? Does a Huawei cluster genuinely competing with Nvidia at the system level change how you think about the long-term trajectory of the global AI hardware race? Or is the remaining chip-level process node gap still too large and too real to close at meaningful scale within the time frame that actually matters? Let me know what you think in the comments.